Now let's apply these formulas to solve a problem. There's a format we should use for solving every problem. The first thing we should do is draw a sketch. So in this particular case, we have a bullet train, a very fast train in Japan. It covers 640 kilometers in 2 hours. So I draw my line like this, and I have my train like so, and I'm going to say it will travel 640 kilometers in 2 hours. So there's a picture that helps me see that. It goes from point A to point B, 640 kilometers in 2 hours. So I made a sketch. The next thing I'm going to do is inventory my quantities. And by that, we're going to list the quantities. We'll put the units in with the right number of significant digits. So my inventory looks like this. My quantities, the first quantity I have is the distance, d, and that is 640 kilometers. Now, when I look at the number 640 written here, I'm unsure as to where the significant digits lie. So this 0 appears to be a placeholder because there's no decimal point there. So what I'm going to say is that this has 2 significant digits. Next, I'm going to record the time as 2 hours. And what I can see is there's only 1 significant digit. Now technically, we never have values that are 1 significant digit because that means they're an estimate. But for the sake of this problem, we're going to treat it as if it's okay to do this. So the next step we have is, now that we have inventoried everything, we're going to convert to standard units using dimensional analysis. Now, kilometers and hours are not standard units. So we've got to go from kilometers to meters. So I have 640 kilometers, and I want to get rid of kilometers. So kilometers goes on the bottom, and we want to go directly to meters. Kilometers is the large one. 1 kilometer is 10 to the 3rd meters. So that means we have 6.4 times 10 to the 5th meters. Similarly, we'll convert hours to seconds. 2 hours, and we want to get rid of hours. 1 hour is 60 minutes, and we want to get rid of minutes. 1 minute is 60 seconds. You can see minutes cancel, hours cancel, we'll be left with seconds, and that gives us 7,200 seconds. So I've now converted my units into standard units. Next, I am going to record the formula I'll use. The formula I'm going to use is the average velocity equals the total distance over the total time. And the total distance in this case was 6.4 times 10 to the 5th. And my time is 7,200 seconds. So I have, first of all, solved for the unknown because it was velocity. I didn't have to do any solving. I substituted in data, and now I'm going to calculate the correct answer and record the unrounded answer. When we divide this out, we get 88.888 repeating meters per second. So we calculated the correct answer and recorded the unrounded answer with units. That's what we have. The next thing we're going to do is round the answer to the correct number of significant digits. Now we had 2 significant digits here, and 1 here, which means that we can really only report one significant digit, which means this here, this 8, will be caused by this 8 to round up to 9. So we have V bar equals 9 times 10 to the 1 meters per second. We have the correct significant digits and units, and we put it in scientific notation, which we actually needed to do in order to represent it correctly. Because had we written 90 meters per second, there's ambiguity about that 0. So really 9 times 10 to the 1 meters per second. And the last step is to analyze the formula using dimensional analysis. Did this actually work? Well, we rewrite our formula. V bar equals d over t. The unit of distance is meter, and the unit of time is second. So the units of velocity are meters per second. Now let's take a look at another sample problem using the same steps. We have Usain Bolt holding the world record at 100 meters in 9.58 seconds. What is his average speed? Well, we begin with a sketch. And we can see that this distance is 100 meters in 9.58 seconds. So we have our sketch. We do an inventory of quantities with units and significant digits. So we are given a distance of 100 meters. Now, the number that's written down here, 100, is interesting because it looks like both zeros are placeholders. But in truth, this is going to be very precise if it's an Olympic track and field. So it's probably more like 100.00 meters. And that would give us 5 significant digits. Then we have our time, which is 9.58 seconds, which gives us 3 significant digits. So we've made an inventory of quantities with the units and the significant digits. We're going to convert to standard units. They already are standard units, meters and seconds. We'll record the formula. V bar equals d over t. We'll solve for the unknown. We're looking for the average speed, so we already have that as well. And substitute data. So we have 100.00 over 9.58. And the answer we get when we divide this out is 10.43841 meters per second. And what we have done is we have calculated our correct answer, unrounded, with units. Now we're going to round the answer to the correct number of significant digits. Well, we had 5 and 3, so our answer can only have 3. And when we examine the 4, the 3 is less than 5, so it remains at 10.4. So we get an average velocity of 10.4 meters per second. So we now have expressed it with the correct number of significant digits with the proper units. Now, we do the same thing, but in scientific notation. Scientific notation, then, is 1.04 times 10 to the 1 meters per second. And that's our average velocity. And we could box our answer to show that's what we want our final answer to be. The last question is to analyze the formula using dimensional analysis. So again, we have v bar equals d over t. Distance was meters, time was seconds, and we can see that meters per second here matches the meters per second here. And our last example here, we're going to consider Usain Bolt again. He also holds the world record in the 200 meters. If he ran the same average speed as the 100 meters, how long would it take him? So here's our situation. We have 200 meters, and there is the race. He's going to run from here to here, but what we know is that his average velocity is going to be 1.04 times 10 to the 1 meters per second. We want to know how long, which is the time. So now when we list our inventory, we have the average velocity, which is known. And we know that it's 1.04 times 10 to the 1 meters per second. However, we need to use the unrounded value in our calculation here. But in any case, we know that this has 3 significant digits. We know the distance is 200 meters, and it again would have many more significant digits than just the 200. And then we are looking for the time in seconds, and we can see using these two numbers we are going to have an answer with 3 significant digits. Now to solve for the unknown. We have v bar equals distance divided by time. We are looking for time, so cross multiplying, we get d equals v bar t, and to get t by itself we divide both sides by v bar, leaving us t equals d over v. So t equals d over v. d is 200.00, and the velocity was 1.04 times 10 to the 1, but unrounded. And when we divide that out, we get an answer of 19.16 seconds. And that's all the digits in that case. Now our answer, we said, can have 3 significant digits. So the time then would be 19.2 seconds. 19.2 seconds. So if he had run the same speed he ran the 100, he would run 19.2 seconds. So you might be wondering, what did he actually run? It actually turns out that he ran it in 19.19 seconds. Very close to the calculated 19.16. The conclusion we draw is that he actually ran faster on average during the 100 meters than he did in the 200 meters. He ran on average a little bit more slowly. It would have taken him longer, it did take him longer to run the 200 meters than if he had run it at his 100 meter pace.